Hey guys, I wasn't a fan of how I explained the calculator portion in the last video, and so what I've decided to do is do the video again. Alright, so we're going to start with problem 1, but I'm also going to do problem 2 in this video. So if you felt like you really understood yesterday's video, then feel free to jump right over to problem 2. It's probably about 5 minutes in. So yeah, let's get going. So, if you watch yesterday's videos, you know that these are my two parametric equations. This is for the horizontal distance, this is for the vertical distance of my projectile. So in problem 1, we have a dart, that's my projectile. It's thrown from a point 5 feet above the ground, so that's going to be my starting height, with an initial velocity of 58 feet per second, so that's going to be my v naught, this v with a little subscript 0. That means v naught, that's how you say that, and it just means your initial velocity, so that's going to be 58 for this problem. At an angle of elevation 41 degrees, so that's what theta is going to be, 41. So the first thing we did is we just wrote our two equations. So we got that x was equal to 58 cosine of 41t. And then we got that y was equal to 5 plus 58 sine 41t minus 16t squared. Oop, t squared. Alright, and remember that I would actually draw a superscript 2 here, but since I'm, on my typing it out, I can't make it go up here as a superscript little 2, but this does mean t squared. Okay? So the next question is, when will the dart hit the ground? So you need to pause and think about what that means, okay? The dart is thrown up from 5 feet, and then it's going to go back down. So what am I really looking for? Well, I'm looking for where y is going to be equal to 0, okay? So the easiest way to do this is to let the calculator do the thinking for you, okay? So you're going to pull up a calculator, you're going to turn it on. If I can get mine to turn on. There it goes. You're going to make sure you are in parametric mode. To get in parametric mode for your calculator, you hit mode. You see PAR, you scroll down to PAR, press enter. Alright, so now I'm in parametric mode. Also, you want to be in degree mode because this was given us as 41 degrees. So we go and change ourselves to 41 degrees. Click y equals. Okay, so now we're going to see we have x sub t and y sub t. So we have our two parametric equations. X equation and the y equation. So we're going to type that in. The x equation was 58 cosine 41t. And then t comes from this button right here. Don't forget that. And then my next equation was the y, which is 5 plus 58 sine 41t minus 16t. I did not mean to click that twice. Sorry. Squared. My 16t squared. Okay, so I typed in those two equations. Sorry, that took a little bit. So now you're going to hit graph. This is the part where yours might differ slightly, but hopefully your graph looks something like this. And you're kind of like, well, that's a cool looking graph. It makes sense because I started at 5 feet up and then I threw the dart upward, but I don't see where in the graph this guy ever goes down. So this is what you want to do. And this is why I messed up on yesterday's video. I didn't mess up. I didn't explain it super clearly. Okay? You want to first hit zoom 0. So go hit zoom 0. Okay? So it's going to take a second to process. Okay, so if you look very carefully, this is where I started with the dart. The dart hits the ground somewhere right here. Now, for me, that's kind of hard to see. So next, I'm going to hit zoom 5. However, if you feel like you can see that, you can hit trace and trace your way over to right here and try to find the closest point to where y is 0. Okay? So I'm going to hit zoom again. And I'm going to go to zoom 5, which is square. It just kind of squares my window up and allows me to get a little bit better of a shot at it. So now I can kind of see a little bit better. The thing is, when I'm thinking to myself about all this, I'm thinking, I just want to know where y is 0. That's all I care about. Okay, so if I want to know where y is 0, I can go to my window and I can go change my y minimum to being 0. Okay, so I went to window, and I'm going down to y minimum, and I'm putting in 0, and I hit graph. Now I see a whole lot more. I threw the dart up starting at 5, I went all the way up, and now I'm back down. So now I feel like I can use my trace feature, and it's going to be much easier for me to trace it all the way over. And remember, I want y to be 0. Now, due to this, these calculators are a little bit on the older side. We're not going to get an exact y equals 0 point, but we can get it pretty close. See how this is y equals 0.667, and my next point is -5. So that means y equaling 0 happens somewhere between those two. And the question was, when will the dart hit the ground? So I'm looking for the time that it hit the ground. So when it was at 0.667, just about to hit the ground, it was at time 2.48. And then after I've gone negative, which wouldn't really happen, but I'm going to be at time 2.6. So it makes most sense to say that the dart hit the ground right at about time 2.5. So that's what I'm going to put here. I'm going to say t equals 2.5. Okay? So the next question is, approximate the maximum height of the dart. At what time will the dart reach maximum height? Well, after we've adjusted our window, our calc can tell us this for us. We can just trace our way back up to the highest point we see on the screen, and it seems to be happening right here. And the highest point, it says approximate the maximum height of the dart. Oh, I was off just a little bit, because you notice I said that was the highest point, but it was 27.39. And then I went to the left one more, it's 27.62. So I'm going to go left one more time to make sure I'm at the highest point, 27.3, so I went down. So 27.62 is the highest the dart went. So the maximum height is 27.62, and the time it took to get there is about 1.18 seconds. So the maximum height, or I'll say max height equaled 27.62. It took 1.18 seconds. How far does the dart travel in the horizontal direction? Okay, so let's think about what that means. I want to know how far it went horizontally. So that's the farthest it went before it hit the ground again. So we need to go back to looking and seeing where did my dart hit the ground, but instead of looking at the time like we did on question B, we want to see how far it went. So we want to look at the x value when we're over there. So we're going to scroll over there, and I'm at the 0.6. So that's, remember, if you remember what we just talked about, 0.667 was the closest point we got to y being on the ground. So we're going to take that same x value, and it's about 108.9 or a 0.68. Let's say, or 0.87. Sorry, 108.87. So let's say that it traveled 108.87 feet in the horizontal direction. Okay, so those are all the answers. I hope that the calculator portion is a little cleared up for you. Okay, so let's go ahead now and go on to our next question. Okay, we're going to go on to question 2. Again, feel free to pause this video and to go back. Or if you're watching this video and you're in my class, feel free to pause and say, hey, Miss Lane, can you come over here and help me with the calculator part real fast? That would be fine, but you better have watched the video, because otherwise I'm going to ask you questions about the video, and if you can't answer them, then I'm going to tell you to watch the video again. Okay? Question 2. An NFL punter at the 15-yard line kicks a football from the height of 4 feet with an initial velocity of 85 feet per second at an angle of elevation of 56 degrees. Okay, so we're going to be using those same two equations, the x and y equation, okay, from the very beginning. So this equation and this equation. So x equals v naught cosine theta times t. So for this problem, x equals v naught. V naught was my initial velocity, so it's 85, cosine of my angle, which is 56, times t, which is time. Y equals starting height. Now, starting height. A lot of students like to put the 15-yard line, but that's just how far down the field he kicked it. That has nothing to do with the starting height. The starting height is actually 4 plus, and it was then v naught sine theta t. So v naught once again, oops, I need to get back in there. V naught once again was 85, my apologies, 85. And then it was sine theta. Theta in this case was 56. T minus 16t squared. So there's our two equations. It says, how far downfield will the football first hit the field? So you got to think about what that means. How far downfield will the football first hit the field. So I'm looking for where the football went up, and then it came back down. And I'm looking for where did it come back down again, okay? So, excuse me, we're going to let our calculator do the thinking once again. So we pull it up, we go to y equals. We're going to type in our new equation, 85 cosine 56, oh, I typed 26, 56 t. Then we're going to type in our new y equation, 4 plus 85 sine 56 t minus 16 t squared. All right, we're going to hit graph. And we see it. Now, we can't see this height though. And that kind of bothers me. I kind of want to be able to see how high it went. So, I'm going to start off by hitting zoom 0. Okay? So that's going to completely redo everything. Okay? You don't have to hit zoom 0. You could just go to your window and adjust it. But I just like hitting zoom 0. And this is a pretty graph. I don't really feel the need to adjust it because I can see everything I need to right here. How far downfield will the football first hit the field? Well, we know the football starts here, gets kicked, and lands right here. So we can hit trace. We can trace our way over. I'm very slow at clicking this button, getting it to move over. Alright, so we're looking again for where y becomes 0, 0.7, and then negative. So it seems that this is going to be the closest to y being 0 that we're going to get. So the question is, how far downfield will the football first hit the field? That's a horizontal direction. So it traveled 211.5 feet. But wait, where did we start on the football field? We started at the 15-yard line. So we could get really technical here. So let me be very clear. I am okay if you come in here and you type an answer of it will first hit the field in 211.54. I did not mean to click that. 211.54 feet. Okay? But if you want to take a moment and get real technical, you can. All right? And you could think to yourself, if this is 211.54 feet and I start at the 15-yard line, okay, I could say, okay, I know that there is 3 feet in every yard. So 200, and let's just round. Let's just make our life easy. 211, let's just call it 212. 212 divided by 3. So that's another 70 yards. That's another 70 yards. Sorry, Kayla walked in. She bothered me in the first video. Now she's bothering me in the second. All right. So that's 70 more yards. So you could say it went to the 85-yard line, but there is an 85-yard line. So you might have to stop and go and think about, where will that hit? I'll leave that as a challenge to any of y'all that are actually interested in that. But if you just want to write it'll first hit the field in 211.54 feet, I'm okay with that. You can see Kayla in the background of this video right now. All right, everyone make sure you say hi to her and comment on her being in the video. All right, next thing is determine the maximum height of the ball above the field. Okay, we can go back to our graph to do that. We go back to our graph and we see that the maximum height's going to be right there. So I hit trace, and I'm just going to go and find where my y value gets the maximum it possibly can. So I'm still going up. My y value is still increasing. 80, 81, 81.58, 81.4. Oh, I went down. 81.58, 81.21, so I went down. So it seems that the highest the football field is ever up is 81.58 feet. So we're going to say the max height is 81.58 feet. What is the hang time? That is the total time the football is in the air. So what we do is we go back to right here, and we're just going to see what is t at that point in time. So we're going to trace all the way back, and we're going to see that the longest that the football was in the air was a total time of 4.45 seconds. So we're going to comment on that. We're going to say the total hang time was 4.45 seconds. Okay, So that answers all these questions. Now again, really